Chapter 3 of Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. This LibriVox recording is in the public domain. Recording by Sandra Knight. www.sandraknight.net. The Universality of Life and Mind. The writer has deemed it advisable to preface his consideration of mind in itself, as well as of substance and motion, with 2 chapters, the purpose of which will be to demonstrate that mind, in some form or degree, is to be found in connection with all things, and that everything has life, and that mind is an accompaniment of all life. To many, the term mind means only the thinking quality of man, or perhaps of the lower animals, and life the property only of such organic creatures. For that reason, it has been deemed advisable to point out that life and mind are found even in the lowest forms of substance, even in the inorganic world. In this chapter, and from now on, the writer shall use the term "the mind," etc., to indicate the particular mental principle of the creature or thing, the bit of mind that is segregated from the rest, and which each person thinks of as mine, just as he thinks of my body as distinguished from the universal supply of substance. The term mind will be used in its universal sense. And the writer intends to use Elmer Gates's term mentation in the sense of effort, action, or effect in or of the mind, in short, mental process. The word is useful, and when one has learned to use it, he will prefer it to the more complicated terms. Remember then, please, mentation means mental process. Mentation includes that which we call thought, as well as some more elementary forms of mental process that we are not in the habit of dignifying by the term thought, which latter we usually reserve for mental process of a higher order. So then, mind is the something of which one's particular mind is composed. The mind is that something possessed by one, by and through which he thinks. Mentation is mental process, and thought is an advanced kind of mentation. At least the said words will be so employed in this book from now on. In this chapter you are asked to consider the fact that life is universal, that everything is alive, and that mind and mentation is an attribute of life, and that, consequently, everything has mind and is able to express a degree of mentation. Forms of life, as we know them, are always seen as possessing 2 aspects, viz. 1. Body, substance, and 2. Mentation, mind. The 2 aspects are always found in combination. There may be living creatures who occupy bodies of so fine a form of substance as to be invisible to the human senses, but their bodies would be substance just as much as is the body of the granite rock. And in order to think, these beings would need to have a material something corresponding to the brain, though it be finer in quality than the rarest gas, vapor, or electric wave. No body without mentation, no mentation without a body. This last is the invariable law of the world of things, and naught but the infinite, that which is above things, can be exempt from that law. In order to grasp the idea of the universality of mind, let us go back to the elementary forms of things, and, step by step, see how mentation manifests itself in every point on the scale from mineral to man, using bodies ranging from the hardest rock to the finest form of known substance, the brain of man. As man advances in the scale of evolution, it creates its own working instrument, the body, including the brain and shapes, and molds it to admit of the fullest possible expression of mentation possible at that stage. Mind is the molder, body and brain that which is molded. And inclination, desire, and will are the motive powers leading to gradual unfoldment, the impelling cause being the craving for satisfaction. We shall make our journey backward, and ignoring beings higher in the scale, we shall start with man, leaving out of the consideration for the moment the fact of the existence of the ego or spirit of man, which is higher than body or mind, and considering the mind of man rather than the man himself, we have our starting point on the downward journey of investigation. We need not devote much attention to the consideration of the mind of man at this stage, though we shall have much to do with it later on. But we may undertake a brief consideration of the descending degrees of mentation as manifested by man, as we pass down the scale in the human family, considering in turn the Newtons, Shakespeares, Emersons, Edisons, and their brothers in intellect, in the field of mathematics, literature, music, art, invention, science, statesmanship, business, skilled workmanship, etc., respectively. From these high levels we pass down gradually through the strata of men of but a slightly lower degree of intellect, down through the strata of the average man, down through the strata of the ignorant man, down through the strata of the lowest type of our own race and time, down through the strata of the barbarian, then on to the savage, then on to the digger Indian, the bushman. What a difference from highest to lowest! A being from another world would doubt that they were all of the same family. Then we rapidly pass through the various strata of the lower animal kingdom, from the comparatively high degree of mentation of the horse, the dog, the elephant, etc., down through the descending scale of the mammals, the degree of mentation becoming less marked at each step of the journey, then on through the bird kingdom, then through the world of reptiles, then through the family of fishes, then through the millions of forms of insect life, including those wonderful creatures, the ant and the bee, then on through the shellfish family, then on through the community of sponges, polyps, and other low forms of life, then on to the vast empire of the microscopic creatures, whose name is legion, then on to the plant life, the highest of which have sensitive cells that resemble brains and nerves, descending by stages to the lower plant life, then still lower to the world of bacteria, microbes, and infusoria, the groups of cells with a common life, the monera, the single cell. The mind that has followed us in this descent of life from the highest form to the cell-like thing merely existing in the slime at the bottom of the ocean, has acquired a sense of awe and sublimity not dreamed of by the man on the street. The degrees of mentation in the lower animal kingdom are well known to all of us, therefore we need not devote much time to their consideration at this time. Although the degree of mentation in some of the lowly forms of animal life are scarcely above that of the plant life, in fact are inferior to that of the highest plants, still we have accustomed ourselves to the use of the word mind in connection with even the lowest animals, while we hesitate to apply the word to the plants. It is true that some of us do not like to think of the lower animals reasoning, so we use the word instinct to denote the degree of mentation of the lower animal. The writer does not object to the word; in fact, he shall use it for the sake of distinguishing between the several mental states. But remember, instinct is but a term used to denote a lesser form of reason, and the instinct of the horse or dog is a fine thing when we consider the reason of the bushman or digger Indian. However, we shall not quarrel about words. Both reason and instinct mean degrees or forms of mentation, the word we are using. The lower forms of animal life exhibit mentation along the lines of sex action, feeling and taste. Then by degrees come smell, hearing, and sight, and then something very like reasoning in the case of the dog, elephant, horse, etc. Mentation everywhere in the animal kingdom in some degree. No doubt about life and mentation there. But what about mentation and life in the plant life? All of you admit that there is life there, but about mentation, well, let us see. Some of you draw the line at the word mind in connection with plants, although you freely admit the existence of life there. Well, remember our axiom, no life without mentation. Let's try to apply it. A moment's reflection will give you instances of mentation among the plants. Science has called it appetency, rather than admit mind, the word appetency being defined as an instinctive tendency on the part of low forms of organic life to perform certain acts necessary for their well-being, such as to select and absorb such particles of matter as serve to support and nourish them. Well, that looks like a degree of mentation, doesn't it? Many young animals evidence little or nothing more than appetency in suckling. We shall adopt the word appetency to designate the mentation in plant life. Remember this, please. Anyone who has raised trees or plants has noticed the instinctive efforts of the plant to reach the water and sunlight. Potatoes in dark cellars have been known to send forth shoots 20 feet in length in order to reach an opening in the wall. Plants have been known to bend over during the night and dip their leaves in a pot of water several inches away. The tendrils of climbing plants seek for the stake or support, and find it too, although it has been changed daily. The tendril will retwine itself after it has been untwisted and bent in another direction. The tips of the roots of the tree are said to show a sensitiveness almost akin to that of the limb of an animal, and evidently possess something akin to nerve matter. Duhamel placed some beans in a cylinder of moist earth. When they began to sprout, he turned the cylinder around quarter way of its circumference, then a little more the next day, and so on, a little each day, until the cylinder had been described a complete revolution, had been turned completely around. Then the beans were taken from the earth, and lo, the roots and sprouts formed a complete spiral. With every turn of the cylinder, the roots and sprouts had changed their position and direction, the roots striving to grow downward, and the sprouts striving to grow upward, until the spiral had formed. Akin to this is the boy's trick of uprooting a sprouting seed and replanting it upside down, in which case the sprouts begin to turn a semicircle until it is able to grow straight up to the surface of the earth, while the roots describe a semicircle until they can grow downward once more. And so on, story after story of appetency or mentation in plants might be told, until we reach the insect-catching species, which even the most conservative observer is forced to admit that, well, it does almost seem like thinking, doesn't it? Any lover of plants, flowers, or trees, and who has been able to study them at first hand, does not need much argument to prove that plant life exhibits traces of mentation, some of it pretty far advanced, too. Some lovers of plants go so far as to claim that one must love plants before they will succeed in growing them, and that the plants feel and respond to the feeling. But the writer does not insist upon this, but merely mentions it in passing. Before leaving the subject of mentation in plants, the writer is tempted to steal a little more space and tell you that plants do more than receive sensations of light and moisture. They exhibit rudimentary taste as well. Haeckel relates an interesting story of an insect-catching plant. He states that while it will bend its leaves when any solid body, excepting a raindrop, touches its surface, still it will secrete its acrid digestive fluid only when that object happens to be nitrogenous, meat or cheese. The plant is able to distinguish its meat diet, its food being insectivorous, and while it will supply its gastric juice for meat and cheese, as well as for the insect, it will not do so for other solids to which it is indifferent. He also mentions the fact that roots of trees and plants are able to taste the different qualities of soil, and will avoid poor soil and plunge into the richer parts of the earth. The sexual organism and life of plants also affords a great field for study to the student hunting for evidences of life and mentation in that kingdom. The motion or circulation of the sap in trees and plants was formerly considered to be due to capillary attraction and purely mechanical laws, but recent scientific experiments have shown it to be a vital action, an evidence of life and mentation, the experiments having proven that if the cell substance of the plant was poisoned or paralyzed, the circulation of sap immediately ceased, although the mechanical principles had not been interfered with in the least. And now on to the mineral kingdom. What, you may cry, mind and mentation in the mineral and chemical world? Surely not. Yes, even in these low planes may be found traces of mental action. There is life everywhere, even there. And where there is life, there is mind. Away back among the chemical principles and the minerals we may go in our search for life and mind. They cannot escape us, even there. End of Chapter 3. Chapter 4 of Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. This LibriVox recording is in the public domain. Recording by Sandra Knight, www.sandraknight.net. Life and Mind Among the Atoms. To the majority of persons, the title of this chapter would seem an absurdity. Not to speak of inorganic mind, the idea of life in the inorganic world would seem a ridiculous paradox to the man on the street, who thinks of substance as dead, lifeless, and inert. And to tell the truth, even science has held this view until a comparatively recent period, laughing to scorn the old occult teaching that the universe is alive and capable of thinking. But the recent discoveries of modern science have changed all this, and we no longer hear science speaking of dead matter or blind force. It recognizes that these terms are meaningless, and that the dreams of the old occultist are coming true. Science confronts a live and thinking universe. She is dazzled by the sight, and would shade her eyes, fearing to see that which she feels must present itself to her vision when her eyes become accustomed to the sight. But a few daring minds among the scientific investigators are dreaming wonderful dreams today, and they tell us in broken tones of the wonderful visions that are passing before their sight. They dare not tell it all, for they fear the ridicule of their fellows. Their visions are of life, universal life. In its investigations of the material, science has penetrated so far into the recesses of things that its most advanced thinkers and investigators now find themselves standing in the presence of the immaterial. Science today is proclaiming the new doctrine, that is the same as the old doctrine of the occultist, the doctrine of life everywhere, life even in the hardest rock. Before entering into our consideration of the evidence of mentation in the inorganic world, let us accustom ourselves to the idea of something like life being found there. It will be better for us to approach the subject by easy stages. Where there is life, there must be mind, so let us first look for evidences of life. The man on the street would require something more tangible than scientific explanations of sensation, attraction, etc. What can we offer him as an illustration? Let us see. Suppose we call the attention of the man to the fact that metals get tired after considerable work without periods of rest. Science calls this the fatigue of elasticity. When the metals are given rest, they recuperate and regain their former elasticity and health. The man may remember that his razor acts this way occasionally, and if he talks the matter over with his barber, his suspicions will be verified. Then, if he consults a musician friend, he will be informed that tuning forks also become tired and lose their vibrating quality until they are given a rest. Then his machinist friend will tell him that machinery in factories must be given a rest occasionally, else it will begin to disintegrate and die. Machinery will go on a strike for a rest if it is overworked. Then metals contrast disease. Science informs us that zinc and tin have been infected, and the infection has spread from sheet to sheet, crumbling the metal into powder. The spread of the infection resembling the spread of a plague among animals or plant life. Science has experimented with copper and iron and has found that these metals may be poisoned with chemicals and will remain in a weakened condition until antidotes are administered. Window glass workers declare that there is such a thing as glass disease that will ruin fine stained glass windows unless the infected panes are removed. The glass disease starts with one pane and spreads gradually to the entire window, and from there to other windows. Metallurgists have found that when metallic ores are put under certain forms of pressure, they seem to lose strength and become weak until the pressure is removed. Do these things mean anything to the man on the street? Another step in the consideration of life in the inorganic world is the realization of the fact that, after all, there is but the very finest line separating the higher forms of mineral life from the lower forms of vegetable life, or the life of those things which we may call either plants or animals. The lifeline is being pushed further back every day by scientific investigation, and the living thing of today was the inanimate thing of yesterday. We hear much talk in the newspapers about some scientist or another discovering life or creating life in some inanimate substance. Bless your hearts, you who are alarmed by these reports. No one can create life in anything, for it already exists there. The discovery is simply the realization of this fact. Science, by means of the microscope, has brought to light forms of living things resembling in appearance the fine dust of inorganic minerals. These low forms of life exhibit but the simplest vital processes, the same very closely resembling chemical processes, although just a shade higher in the scale. Living creatures have been found which could be dried and laid aside like dust for several years, and then revived by being immersed in water, when they would resume their vital process as if they had been awakened from a sleep. Forms of life called bacilli have been discovered that can pass through degrees of heat and cold that can be expressed only by vague symbols or figures, the heat and cold being so intense that the unscientific mind cannot imagine it. In appearance, the diatoms resemble the chemical crystals. These diatoms are minute, one-celled living things, having a hard but thin silicous covering or shell of extreme delicacy. They are what are known as microscopic creatures, that is, visible only through the microscope. Some of them are so small that it would take 1,000 or more to cover the head of a pin. But remember this, the microscope reveals them as living creatures, performing vital functions. They are found in the deep waters of the ocean. To the naked eye they appear like fine sand or dirt, but under the most powerful microscope they are seen to comprise many species and varieties, exhibiting many peculiar shapes and forms. In fact, they have been called living geometrical forms, their shapes and appearances almost exactly resembling those of the chemical and mineral crystals. Science informs us that these and similar microscopic creatures number thousands of families or species, and it is thought that the varieties of microscopic creatures outnumber the varieties of creatures visible to the unaided sight. And remember that there is probably a still greater world of submicroscopic creatures that is a world invisible even when the most powerful microscope is used. Who knows what wonders are to be found there, what forms of creatures live and move and have their being there. In passing by the subject of the resemblance between the outward forms of living things and the crystals, it is interesting to note how the crystals of frost and ice resemble the forms of leaves, branches, flowers, foliage, etc. The pane of glass covered with these frosty forms resembles a garden. The disk of saltpeter under the effect of polarized light very closely resembles the form of the orchid. Recent scientific experiments have shown that certain metallic salts, when subjected to a galvanic current, group themselves around one of the poles of the battery and assume a mushroom-like shape and appearance. At first they seem to be transparent, but gradually they assume color, the top becoming a bright red, with the underside showing a pale rose color, the stem being a pale straw color. The discoverers of these peculiar forms called them by the German equivalent for inorganic mushrooms, but even this term seems scarcely worthy of them, for they even show a trace of something like organs. Under the microscope they are seen to have fine canals or vein-like channels running through their stems from top to base, and through these veins the thing absorbed fresh material and actually grew like low forms of fungus life. Were these things merely minerals or chemical substances, or were they low forms of organic life? The lines between the inorganic and the organic are being wiped out rapidly. The supreme power that caused life to be, caused it to all, and did not divide its manifestations into dead things and live things, but breathed into all the breath of life. And the more clearly we see the actual evidence of this, the greater does that supreme power seem to us. A very low form of living creatures called the Monera is held by science to be the one of the strands of the connecting link between the organic and inorganic worlds. The Monera are the lowest and simplest form, at least so far known, of organic life. They may be said to be organic creatures without organs, being but little more than simple cells. Tiny globules of plasm surrounded by a thin membrane, their sole vital function being the absorption of nourishment through the pores of their covering, just as a piece of chalk would absorb water, and the consequent conversions of the nourishment into material for growth, the whole process resembling chemical action. The Monera reproduce their kind simply by cleavage or separation of the substance of the mother cell into two, and so on, being little more than the growth of crystals. The Monera are everywhere recognized without question as living creatures, but they exhibit merely a trace more of life than do certain forms of crystal. The difficulty in considering crystals as living things is partially due to the outward form and substance, so different from the form and substance of the higher living things. But we have seen that the diatoms took on shapes in crystals, and that the outer shells or covering was similar to silica, a mineral, the inner substance being but a tiny speck of plasm similar to that of the substance of a plant cell. And then we may look to the tiny bit of chalk dust which was once the skeleton form of a living creature. The same is true of coral. In the very low forms of life, the skeleton or form is the thing most apparent, the plasm of living substance being still smaller and less apparent, and yet the skeleton or shell was formed by the vital processes of the creature, and was a part of its body just as is the skeleton or bony structure of the higher animals. And in the same sense it is living substance. And remember that there is but little difference between these bodies of the low forms of life and the bodies of crystals, and the chemical constituents of its plasmic inner body is but slightly different from that of the crystals, and its nature and vital process are by a shade higher in the scale than those of the crystals. You may ask why we have said so much of crystals. The reason is just this: science has begun to think of crystals as semi-living things, and its most advanced investigators and thinkers go further and assert that the crystals are alive. Crystallization is an evidence of life process. Crystals arrange themselves in well-known and well-defined shapes, direction and order of formation being observed implicitly. Each crystal follows the laws and habits of its kind, just as do plants and animals. Its lines of crystallization are mathematically perfect and according to the laws of its being. Not only this, but some substances have a range of 6 or 7 different forms of crystal forms possible to them. In some cases, a chemical element assumes one form of crystallization when it manifests as one mineral, and a second form when it manifests in another form. In each case, however, it manifests along well-known and recognized courses of action, movement, and shapes. Crystals may be killed by a strong electrical discharge, that is, they are so affected that they disintegrate, their atoms separating to form new combinations, just as is the case with the bodies of higher forms of life. Some scientists have gone so far as to claim that they had discovered something akin to rudimentary sex action in certain crystals, resembling the sex process of the lowest plant life. But this has not, as yet, been positively established, although it seems probable and reasonable. A recent writer in one of the magazines has said, "Crystallization, as we are to learn now, is not a mere mechanical grouping of dead atoms. It is a birth." This may seem mere scientific poetry, until the process of crystallization is carefully studied, when it will be seen to give evidence not only of something like vital and mental action, but also something very much like reproductive functioning of the lower forms of life. There is an assimilation of material to build up the crystal in the first place, just as an animal assimilates matter to build up its shell, or a tree to form its bark. The form of the crystal is truly its body, and behind and in that body there is something at work that is not the body, but which is forming it. And later on that crystal increases in size and then begins to separate into two, throwing off a smaller crystal, identical in form with the parent crystal. This manner of reproduction is almost identical with the process of reproduction in the lower forms of life, which consist merely of a like separation of the parent form into two and the throwing off of the offspring. The principal difference between the growth of crystals and of the Monera is that the crystals grow by absorbing fresh matter and attaching it to their outer surface, while the Monera grow by absorbing fresh material and growing outwardly from within. But this may be accounted for by the difference in the density of their bodies, the crystal being very solid while the Monera is like a thin jelly. If the crystal had a soft interior, it could grow like the Monera or diatom, but then it would be a diatom. The process of crystallization is accountable only by the theory that in the crystal there exists something like life and mentation. There is something more than mere mechanical motion or blind chance at work here. Does not the process of crystallization look like rudimentary purposive action? It may be said that it is movement and action in accordance with some established law of nature, granted, but is not that also true of the physical processes and growth of higher forms of life? Is the forming of the crystal form to be considered as a mechanical effect, and the forming of the shell of the Monera to be considered a mental and vital action? If so, wherefore? The point is that crystals act as if they are alive, and capable of assimilation, growth, and reproduction in a manner and degree differing but very slightly from corresponding functioning of the lower forms of life. Verily, the crystals are alive, and if alive they must have at least a trace of mind. Does it not appear that they exhibit something very like both? Quoting from a recent writer, let us notice that recent investigations in the new department of science, which has been termed plasmology, show in crystals phenomena which are absolutely analogous to vital phenomena, so much so that photographs of certain forms produced in the changes of crystals appear to be almost exact duplicates of those in the various lower forms of microbes. The question has been raised as to whether the microbe is no more alive than the crystal, or the latter equally endowed with life as is the former. And now another step in our search for life. Remember that the hardest rocks are composed of crystals of certain kinds, and if the higher crystals have life, then it is only fair to suppose that the lower and cruder forms are likewise endowed, even if in a still lower degree. And if all crystals are endowed with life, then the most solid rocks, being composed of aggregations of crystals, must be masses of inorganic life, and consequently of inorganic mind. A crystal, according to Webster, is the regular form bound by plane surfaces, which a substance tends to assume in solidifying through the inherent powers of cohesive attraction. That definition of Webster tells the whole story, and we see that a crystal is merely a regular form of a substance, which the substance tends to assume in solidifying, that is, in reassuming a solid form after being in a liquid or melted state. And that is just what all the rocks of the earth did when they emerged from the melted state in which they existed in the early days of the world's history. And this tendency that caused them to solidify and assume certain crystal forms, and which must have existed potentially through the melted state, what of that? What is this tendency or force? The definition answers: the inherent powers of cohesive attraction. So here is cohesive attraction, that we shall consider fully in forthcoming chapters of this book. Inherent, too, the definition says. What is inherent? Let us see. Webster defines inherent as permanently existing. So this power of cohesive attraction permanently existed in the substance or else in connection with it. Let us take another look at cohesive attraction. Cohesive attraction is that form of universal attraction that causes the molecules of a body to draw together. That invisible power of the molecule by which it draws another molecule toward itself, and itself toward the other. The manifestation of which power by several molecules tends to draw each of them together. We shall learn of these particles of substance called molecules before long. It is a primal cause of motion, this mutual attraction and drawing power. Now, is it reasonable to assume that this wonderful power is a mere blind force? Is it not more reasonable to think of it as a form of vital action, life action? Dead things could not manifest this force and action. And if this cohesive attraction is an evidence of life, then all substance must have life manifesting through it. Not only the rocks, but the soil and earth and dirt, for they are but crumbled rock. And when we thus consider substance as being the body through which life is manifesting, we must not lose sight of the molecules and atoms in our consideration of the mass. A bit of rock, crystal, or dirt is but an aggregation of countless molecules, grouped together in certain crystallized shapes and forms, each having characteristics of its own. These molecules cling together in accordance with their mutual attractive powers. And each of these molecules is composed of a number of atoms which cling together in accordance with chemical affinity or chemism, but which is but another name for attraction or cohesion, and which form a little family called a molecule. And these atoms are composed of corpuscles. We will waive the consideration of the corpuscle for the moment, but even if we consider it, we only carry the subject back a step farther. What we wish to say could be said even if there were 10 further divisions of substance, or 1,000,000 for that matter. The point we wish you to consider now is that we must separate the mass into its constituents, its molecules, atoms, and even corpuscles, in our search for the life in the mineral and chemical world. If there is life in the mass, there must be life in the molecule, atom, and corpuscle. Now, do we find it there? Certainly, for the tiniest atom manifests its attractive power, and not only does it draw other atoms to itself by virtue thereof, but it even goes a step further and shows a preference, a degree of liking in its mutual relations with other atoms. We shall see in future chapters that there is desire, love, marriage, and divorce among the chemical atoms. We shall consider the flirtations and love affairs of certain atoms. We shall see how an atom will leave another and fly to a new charmer. We shall have many evidences of the atom's power to receive sensations and to respond to the same. Nothing dead about this, is there? The atom is very much alive. The attraction, affinity, and motions of the atom give a certain evidence of something very much like life, as we see it in higher forms. In the atom exists all the life that causes crystallization, and in the atom lies that which causes force and motion to manifest. Verily, the atom lives and moves and has its being. And so our journey is ended. We have traced life to its last stages of manifestation, and we have found it there, and at each step of the journey. But stop, we have not completed our journey. We have but begun it. Why, some of us may cry, how can we go back of the atom or electron? The answer is into the ether. Yes, back of the atom and the corpuscle is said by science to lie that wonderful paradoxical something they call the universal ether. That something that science has considered the womb of matter and force. Something that is different from anything ever known or dreamed of by man. That something which science has labored so diligently to build up, and which it has used as an explanation for so much phenomena, but regarding which, of very recent date, there has begun to grow a distrust and a suspicion owing to the discovery of radiant matter and things that followed in its train. But notwithstanding these shadowy suspicions, science still asserts in belief in the constancy and integrity of the ether, and it behooves us to investigate that wonderful region in which it dwells, in order to see whether life and mind are also to be found there. We think that, in the words of the street, we shall find that they are very much there. And so in later chapters of this book we shall consider the ethereal region very fully. But before doing so, we had better give substance and motion in all their forms a careful consideration, for a correct understanding of them is vitally necessary for an intelligent conception of the ideas underlying the philosophy to be herein set forth. Now pray do not leave this chapter with the belief that the writer has said that the particles of inorganic substance are endowed with conscious reasoning powers. Nothing of the kind has been said. Nothing of the kind is meant. The life and mind evidenced in the particles are but the faintest glimmerings. There is no sign of consciousness or reasoning. The mind exhibited is less than that of the plant, yes, less than even that of the cell of the plant. The life is evidenced by power to move, and the mind is evidenced by the ability to receive impressions and to respond to the same by evidencing force and movement. There is no evidence of consciousness or understanding in these mental processes. Consciousness is not an essential attribute of life or mind action. In fact, but a small part of even the mentation of man is performed in the field of consciousness. Nearly all of his bodily functions are beneath the field of consciousness. One does not consciously regulate the beating of his heart, the circulation of his blood, the digestion and assimilation of his food, the tearing down and building up work of the cells, the work of the organs, etc., etc. Yes, these processes are all mental processes, and far from mere mechanical movements or chemical processes as some imagine. Let the spark of life leave the body and the processes stop, although all the chemicals are still there, and the mechanical movements might go on unhindered. The particles of substance have enough life and mind to enable them to move, receive, and respond to impressions, and to exert force in accordance with the law of attraction, but there it stops. The crystals show signs of something like taking nourishment, but the real taking of food may be said to commence with the Monera. Not until high degrees of life and mind are attained do creatures begin to exhibit consciousness, and that which is called understanding is still higher in the scale, and not until man is reached does the faculty of turning the mental searchlight inward manifest itself. These matters are mentioned here merely to prevent misunderstanding and misapprehension. But still, do not forget, the particles of substance receive impressions and respond thereto. They act and exert force and energy. They manifest life and mentation. End of chapter 4. Chapter 5 of Dynamic Thought or the Law of Vibrant Energy by William Walker Atkinson. This LibriVox recording is in the public domain. Recording by Sandra Knight, www.sandraknight.net. The Story of Substance. As we stated in a former chapter, there are two aspects of all things, viz. 1. Substance, 2. Mind. In this and the following two chapters we shall consider the first one, substance, which science calls matter. Perhaps it would be as well to begin by asking ourselves the question, what is substance? The answer seems to be anything that takes up room, the body aspect of things, matter occupying space, etc. Some writers have spoken of substance as something tangible that can be felt. But this definition will not do, for there are forms of substance too fine to be felt. And so perhaps the definition, the body of things, is as good a definition as any, taken in connection with the thought that it takes up room. Science divides substance, which it calls matter, into four general classes, viz. 1. Solid matter, which is substance, the parts of which closely adhere and resist impression, such as stone, wood, flesh, etc., the degrees of solidity varying greatly, and sometimes shading into the next class, which is called 2. Liquid matter, which may be described as substance, the parts of which have a free motion among themselves and easily yield to impression, such as water, molasses, etc., the degree of fluidity ranging from some liquids that flow very slowly, such as hot pitch, up to others that flow very freely, such as water, wine, etc., the property of fluidity being also shared by the next higher class, which is called 3. Aeriform matter, which is substance in the form of elastic fluid, such as air, gas, vapor, etc., and radiant matter, which is of recent recognition and which is an ultra-gaseous form of substance utterly unlike anything ever before known, consisting of the tiniest particles of corpuscles of substance finer and more subtle and the rarest form of atomic substance known to science. The three classes are well represented by 1. Earth, solid; 2. Water, liquid; 3. Air, aeriform; 4. The corpuscles or electrons or particles of electrified substance, first noticed in connection with the X-rays, radium, etc. But it must be remembered that these four classes of substance are not fixed or permanent. On the contrary, they are changeable either under pressure when subjected to heat or under the influence of electricity, etc. In fact, the word condition is more applicable than the term class. The condition or class of a particle of substance may be changed into another class or condition by the application of the agencies above named. The same substance may exist in 2 or 3 classes under different circumstances. Solids may be changed into liquids and liquids into gases, and vice versa. Metals may be melted, then changed into gas, according to the degree of heat applied. Liquids may be changed into vapor by the application of heat, or into solids by the withdrawal of heat. For an example, we may turn to water, which is a solid in the condition of ice, a liquid in the condition of water, and steam in the condition of vapor. Quicksilver is a metal which is in a liquid condition in our ordinary temperature, but which becomes a solid when subjected to a very low degree of temperature, and may be transformed into a gas under a high degree of heat. Air is a vapor in our ordinary temperature, but has been transformed into liquid air under tremendous pressure, which produced a very low degree of temperature, and theoretically it may be transformed into a solid under a sufficiently low degree of temperature, although so far science has not been able to produce a degree of cold sufficient to freeze the liquid air. It is all a matter of freeze, melt, and evaporate in all forms of substance, and any substance, at least theoretically, is capable of being subjected to any of the 3 conditions just named, and being manifested in the respective conditions of solid, liquid, and aeriform. This may actually be accomplished with the majority of substances at this time, although in some instances we are not able to produce a sufficiently high temperature to melt and evaporate certain solid substances, on the one hand, or a sufficiently low degree of temperature to liquefy or freeze solid certain vapors. But the intense heat of the center of the earth is able to melt rocks and show them as liquid lava flowing from volcanoes, and science teaches that the solid substance of the earth and other planets, suns, etc., existed in the shape of a vapor at one time, and would again take on that condition in case of a collision with another great body, which convert motion into intense heat that would first melt and then vaporize every solid particle of which the earth is composed. If the sun's heat were completely to die out, the cold would be so intense that the air around the earth and all the gases and vapors would be frozen to solids. In physics, the term gas is generally applied to a substance that is aeriform in ordinary temperature, but which may be liquefied in a low temperature. The term vapor being generally applied to the aeriform condition of substances that are solid or liquid in our ordinary temperatures, but which may be evaporated by heat and thus transformed into an aeriform condition, resuming their original form upon cooling. These terms, however, are technical, and practically there is no difference between a gas and a vapor. In the above statements regarding the possibility of the transformation of each of the several forms of substance into other forms, the reference has been applied only to the 3 better forms, i.e., solid, liquid, and aeriform. The 4th form or state of substance, known as radiant matter, is of too recent discovery to admit of its properties being accurately observed. The best and latest opinion of science, however, is that it constitutes what may be called primal matter, that is, substance from which all other forms, states, kinds, and varieties of substance arise, the stuff from which they are manufactured. Science seems to be discarding the ether theory of the origin of matter in favor of this primal matter. Physical science divides substance into masses, molecules, and atoms. That is, the old physical science did. But the later investigators now see that even the atom may be subdivided. But the old terms may as well be used, at least for the time being. Let us consider these divisions. A mass is a quantity of substance considered as a whole, but which is composed of a collection or combination of parts, molecules. A lump of coal, a piece of iron, a portion of meat, even a drop of water, is a mass. The only requisite for a mass is that it contains two or more parts or molecules. Therefore, a mass is a collection or combination of two or more molecules considered as a whole. A molecule is the physical unit of substance, or, in other words, the smallest part of any kind of substance that can exist by itself and still remain that particular kind of substance, but not the smallest chemical part. The latter is called an atom, and atoms combine to form a molecule. The molecule exists as a unit and cannot be split or separated by physical means, although it may be separated into atoms by chemical means. In order that we may form a clear idea of the molecule, let us take a very small mass of matter. A drop of water, for instance. This drop of water is a mass composed of a great number of molecules. It may be divided and subdivided into smaller and still smaller parts. This division may be carried on until it reaches a point where our sight and instruments are unable to make a further subdivision. But theoretically, the work may be carried on still further until at last a limit is reached where we are unable to divide the water into any smaller parts, without separating its chemical constituents from each other, in which latter case there would be no water at all. Its chemical constituents, or atoms, having separated and now appearing as two atoms of hydrogen and one atom of oxygen, separated and apart and no longer forming a molecule of water. Well, this smallest possible part of water, or any other form of substance, is a molecule. Remember, the molecule is the smallest part of that kind of substance that can be produced by division and subdivision without destroying the kind of the substance. It is the smallest part of any kind of substance that can exist by itself and maintain its kind. In order that you may grasp the minuteness of the molecule, we may mention that science claims that no molecule, even the largest, is of sufficient magnitude to be seen under even the strongest microscope. It has been calculated that if a drop of water as large as a pea were magnified to the size of the earth, the molecules would then appear no larger than the original drop. The space between the molecules is believed to be considerably larger than the molecules themselves. The figures that are necessary to use in connection with molecular substance are likely to stagger the imagination. Besides speaking of the molecules of inorganic substance, it may be interesting to note that a spider's thread is so fine that a piece of it large enough to circle the earth would weigh only half a pound. And yet each thread is composed of 6,000 filaments. And each of these minute filaments may be divided into tiny bits, and each bit will still be a mass of substance containing thousands of molecules and their constituent chemical atoms. There are living, microscopic creatures so small that 5 millions of them might be crowded into a space the size of a pinhead. And yet each of them have organs, and in these organs fluids circulate. Try to figure out the size of the molecules of the fluids circulating in these tiny organs, not to speak of the chemical atoms. When you handle a coin, an infinitesimal portion of it is worn off. Can you figure the size of the molecules composing that part? When a rose throws off its perfume, it emanates tiny particles of itself. Can you measure or weigh the molecules composing that odor? The human mind is compelled to realize the finiteness when it considers these things. But we have only just begun to consider the smallness of things. An atom is the chemical unit of substance, that is, the smallest chemical part that can enter into combination. It has been considered indivisible, that is, incapable of further subdivision. That is, it has been so considered until very recently, but the latest discoveries have exploded this idea and have shown the atom is composed of certain other things, as we shall see a little later on. Still, we may use the atom as a very good unit of measure, for it still represents the unit of chemical substance, just as the molecule is the unit of physical substance. In order that you may understand the difference between molecules and atoms, physical units, and chemical units, let us give you a few examples. Take a molecule of water, the physical unit, you remember. When it is chemically separated or analyzed, it is found to contain 2 atoms of hydrogen and 1 atom of oxygen. Both chemical units, remember, which when united and combined form water, but which when separated are simple atoms of certain chemical gases. The proportion in water is always the same, 2 of hydrogen and 1 of oxygen. This is the only partnership that will form water. The molecule of table salt contains 1 atom of sodium and 1 of chlorine. The molecule of air contains 5 chemical gases, of which nitrogen and oxygen are the principal ones, the proportion being about 3 parts of nitrogen to 1 of oxygen. Some molecules are far more complex. For instance, the molecule of sugar is composed of 45 chemical atoms, and sulfuric acid of 7. An atom is estimated at 1/250 millionth of an inch in diameter. But this is not all. The old theory of the finality and ultimateness of the atom has been shattered by the recent discoveries of science. The atom of hydrogen was formerly considered to be the refinement of substance, the ultimate atom, the smallest and finest atom possible or known, the last thing that could be imagined about substance. Some even went so far as to declare that the atom of hydrogen was the ultimate element. That is, the element out of which all other atoms were made, the mother of atoms. It was supposed that all other atoms of matter were composed of a varying number of hydrogen atoms, which themselves were vortex rings in the ether, and that analysis could go no further. Science rested on its oars and pronounced the work of a century completed. But alas, no sooner was the position reached than the discovery of radiant matter and the formulation of the corpuscle theory brought down the whole theoretical structure, and science was compelled to take up the hunt again, and to probe further into the inner recesses of things for the ultimate thing. But nevertheless, atoms still exist, although their finality is no longer urged. The facts remain, although the theory has fallen. Let us see about this latest theory, the corpuscle or electron theory. The discovery of radiant matter and the investigation of the late discovery of radium has led to the further discovery that each atom, instead of being a thing in itself, is a little mass containing numerous other things called corpuscles or electrons because electrified. The theory is this, briefly, that each atom is a minute mass of substance containing a number of electrified particles which are known as electrons, in constant motion and vibration, revolving around each other as do the planets, suns, and moons of the universe. In fact, each chemical atom is like unto a universe in itself. The simplest atom, that which was supposed to be the ultimate atom, the atom of hydrogen, is supposed to contain within its tiny self no less than 1,000 minute corpuscles, which because electrified are called electron, revolving and fixed in regular orbits within the containing globe of the atom. The more complex forms of atoms are supposed to contain a far greater number of electrons, the authorities estimating those in an atom of oxygen at 10,000, those in an atom of gold 100,000, and those in an atom of radium 150,000. These figures are of course mere scientific guesses, but when compared with the similar guess regarding the size of the atom, they give a startling illustration of the size of the newly discovered corpuscle or electron. Another authority for an illustration asks us to consider a great globe about 100 feet in diameter, that is, of course, 100 feet through its center. Let the globe represent the atom. Then imagine 1,000 minute specks, each the size of a pinpoint, composed of substance, and each containing, as in a capsule, an atom of electricity. Each speck is revolving around each other in a regular orbit in the great 100 feet through globe, and keeping well away from one another. That will give you an idea of the relative size of the electrons and atoms, and the room that the former have to move about in. Good many feet between each, you will notice. Lots of room and plenty to spare. try to figure out the size of an electron. Many readers of the magazines have been confused as to the relation between the corpuscles and the electrons, or ions as some have called the latter. The matter is very simple. They are both the same. The corpuscle is the tiny particle of matter, which, because it is electrified and has thus become the unit of electricity, is called an electron. From the viewpoint of substance, we call the tiny particle a corpuscle. From the viewpoint of electricity, we call it an electron. These electrons are the tiny particles that pour forth from the pole in the Crookes tube and constitute what are known as X-rays, cathode rays, Becquerel rays, etc. They also are the particles that are thrown off and emitted by radium and similar substances. They exist in the atom, as explained, but also are found free and independent, and in the last condition or state are thrown off in the aforesaid rays and by radium, etc. So far, the corpuscles are known only as charged with electricity, and the electron only as a tiny charge of electricity with which the corpuscle is charged. But science dreams of corpuscles of substance other than electrons, in which case the old occult teachings of light dust and heat dust, etc., will be verified. The electron contains a powerful charge of electricity, as much in fact as an atom 1,000 to 150,000 times its size will carry. But science is wondering how these highly charged particles manage to hold together in the atom, so rigidly coherent as to appear indestructible. We think that we may get a hint at the matter a little later on in this book. Science, or at least some scientists, are wondering whether the whirl or vibration of the corpuscle might not produce that which we call electricity, and whether, when the motion is intensified, waves of electricity will not be emitted. The writer fully agrees with the idea and finds that it fits closely his own theories regarding substance and motion. But the reader is cautioned against falling into the error of many recent popular writers on the subject, some of whom have used terms calculated to convey the idea that the corpuscle, electron, is electricity itself, rather than tiny particles of substance called corpuscles, charged with the unitary charge of electricity and therefore called electrons. But for that matter, electricity is only known to us as associated with some form of substance and not as a thing in itself. We shall see the reason for this as we proceed with this book. These corpuscles are destined to play a most important part in the theories of science from now on. They already have overturned several very carefully and laboriously erected theoretical structures, and many more will follow. Among the many important ones evidently doomed to the dust heap being the vortex ring atom theory, and other theories built upon the etheric origin of matter, and other theories concerning the ether, even to the extent of breaking down the theory of the ether itself, which theory had almost come to be considered a law. We shall further consider the corpuscles and their qualities, characteristics, etc. in the next chapter, for they have an important bearing upon the theories advanced in the course of the study of this book. End of chapter 5.